Everyone thinks AI is built with genius code, but the terrifying reality is the code is the cheap part. You can download powerful AI algorithms online for free right now. The real cost of AI is something far bigger: electricity, data, silicon, infrastructure. And at the highest level, training a single frontier AI model can cost more than a Hollywood blockbuster. Most people see AI as a chatbot on a screen, but behind every prompt is an industrial machine. Entire buildings packed with thousands of GPUs, cooling systems running 24 hours a day, power grids feeding enormous amounts of electricity into giant AI clusters. The modern AI race is no longer just about intelligence, it's about who can afford the infrastructure. Because today, artificial intelligence is becoming one of the most resource hungry technologies humanity has ever built. Before an AI can speak, it has to learn, and it learns from the data. Massive amounts of data, books, Wikipedia, scientific papers, YouTube subtitles, code repositories, forms, social media posts. But there is a problem. The raw internet is a mess. Spam, fake information, duplicate text, toxic content, low quality garbage. So before training even begins, companies spend months cleaning and filtering data. In many AI projects, teams spend the majority of their time preparing the usable datasets, and this stage alone can cause enormous amounts of money. Companies buy licensed datasets, pay for copyrighted material access, hire thousands of contractors to manually review AI outputs. Some AI firms spend over $500,000 before the model even starts training. Because a bad data creates a bad intelligence, and if your data set is flawed, your AI becomes flawed too. Then comes the pace that changes everything: compute. This is where AI transforms from a software project into an industrial scale operation. To train advanced AI models, companies use specialized chips called GPUs. And right now, NVIDIA dominates this world. A single high-end NVIDIA H100 GPU can cost around $30,000. That's one chip. Now imagine needing thousands of them connected together, running non-stop for months. A small startup training a lightweight AI model might spend anywhere from 50,000 to several $100,000. But once models become larger, the costs explode exponentially. A serious enterprise level model may require hundreds of GPUs operating continuously across giant cloud clusters. Training costs can quickly jump into the millions, and the frontier AI systems, that's completely different universe. Companies like OpenAI, Google, and Meta reportedly use tens of thousands of GPUs inside a hyperscale data centers. One large scale training run can cost between tens of millions to over $100 million for a single version of a model. And the terrifying part, training isn't instant. Some runs can continue for weeks or even months, meaning thousands of GPUs are consuming electricity every second. One software mistake, one failed configuration, one instability halfway through training, and millions of dollars can vanish just like that. But GPUs are only part of the story, because AI has another massive appetite: power. Modern AI systems consume enormous amounts of electricity, and those GPUs generate incredible heat, which means giant cooling systems are required just to stop the hardware from overheating. So modern AI data centers consume as much as electricity as small towns. Tech companies are now racing to secure power infrastructure specifically for AI expansion. Entire regions are experiencing increased energy demand because of AI compute growth. In some ways, AI isn't just competing for intelligence anymore. It's competing for energy. But let's say the training succeeds. The AI is finished. You're done spending money, right? Wrong. Because now comes the inference, the forever cost. Every time someone types a prompt into an AI, GPUs activate instantly to generate a response. Unlike traditional apps, large language models require massive computational resources for every single interaction. That means companies must continuously rent or operate huge numbers of servers just to keep their AI online 24 hours a day, 7 days a week. Even medium sized AI systems can cost tens of thousands of dollars every month just to stay operational. And if millions of users suddenly arrive, costs skyrocket instantly. A badly optimized AI product can burn through massive amounts of compute overnight, which is why many AI startups don't fail because their technology is bad. They fail because the infrastructure costs crush them. And this is why AI is often called the new space race. The barrier to entry is no longer just intelligence, it's capital. Who can afford the chips? Who can secure the electricity? Who can build the data centers? Who can sustain the infrastructure long enough to stay ahead? The future of AI may not be controlled by the companies with the smartest ideas, but by the companies powerful enough to feed the machine. So, the next time an AI answers your question in 2 seconds, remember what's happening behind the screen. Thousands of GPUs, massive power grids, industrial cooling systems, warehouses full of machines, all working together to generate a few lines of text. Artificial intelligence may look digital, but underneath it all, it's built on the raw physical power.